sorry for the late. So I can't upload the slide to the event site. So this is my trouble. Sorry. Okay, I started my session. Okay, thanks for coming to this my session. This session is talks about the Fluentd project introduction. So in this conference, we have two sessions for the Fluentd project. So one is this Fluentd project introduction, and the second is tomorrow's deep dive session. Deep dive session, it's this Eduardo will talk about the Fluentd for the Fluentd for introduction. So my talk is Fluentd, not Fluentd. Okay. Okay, let's talk to my session. So in first, I talk about the overview of the Fluentd, so the concept of the Fluentd. Okay, this is a list of the Fluentd concepts. So what's Fluentd? So Fluentd is designed for the streaming data collection, not the batch model. So it means Fluentd continues to read logs from the, any data sources and continues to write data to the destination. For example, pouring the HTTP endpoints and the collected data and send to the collected data to the data stores. For example, S3 or RDBMS or other local files. So this is important is continuous processing. So the Fluentd is consists of the core and the plugin parts. So Fluentd's core provides the important features for the data collection. The plugins cover the Fluentd's user use cases, for example, reading data or writing data. So core provides the important feature. So plugin focuses on the core logic of the reading data or writing data. And the Fluentd is written in Ruby and C. So I/O heavy or other CPU heavy parts is written in C. And the Fluentd's core, so for example, plugins or other core parts is written in Ruby. So this is for flexibility. This Ruby is for flexibility, and C is for the performance. And the Fluentd uses Ruby gems for the plugin distribution, so we can use the whole Ruby ecosystem for the writing or plugin distribution. And the Fluentd has several installation ways for your deployments. So one is Ruby gems, because Fluentd itself is a Ruby library. So you can use, if you are familiar with Ruby, you can use the Fluentd gem library directly. And the other ways is ARM-TV. So this my company provides the packages for the operating systems. So one is the RPM for Red Hat Linux or CentOS, and dev packages for the Debian and Ubuntu. And the Fluentd runs on the Windows, so we also provide the MSI package for the Windows servers. So you can choose the installation ways for your needs. But of course, Fluentd provides container images for Docker and the Kubernetes. So you can run Fluentd on the your container runtimes. And the Fluentd is the very important is Fluentd is a logging part in the CNCF. So Kubernetes or other related products uses Fluentd for their data log collection. Okay, and this is one example of the streaming log collection. So in the old days, we use the rsync or other transfer tools. The problem is this approach is needed to wait the all data are logged in the local files. But in streaming log collection, for example, Fluentd is monitors the log files, and if application writes the logs to the local files, Fluentd read logs immediately and send data to the destination. This can be configured. So by popular cases, user send to data to second unit, so 1 second or 10 seconds to the central servers. So we can see that the newer data is quickly on the central servers or on the Hadoop or BigQuery or S3. And I said that Fluentd consists of the core and path. So Fluentd core and the plugin. So by plugins, we can collect any data sources from any data sources and send data to any destination. So Fluentd is a glue in the data pipeline. You don't need to write any log collection daemons for your own use cases. So Fluentd plugin covers your case. Okay. This is the overview of the Fluentd. So next is the architecture. This chapter shows how Fluentd works. Okay. And this is the design of Fluentd. I said the Fluentd consists of core and plugins. This list is the details of each part. So Fluentd core handles the event buffering on the read line. So this is very important for the stable deployment. So Fluentd core supports the buffering of the read line and the error handling. So each plugin developer don't need to consider how to retrieve how to buffer before data writing. So Fluentd developer can focus on how to read data from the data sources and how to write data to the destination. So focuses on the core logic. So this is why Fluentd has lots of plugins in the worldwide. Maybe currently over 500 plugins in the Ruby gems. This is also important architecture. So Fluentd, this is Fluentd event structure. So it means in Fluentd, one event has these three elements. So time and tag and record. So this is one Fluentd event. So for example, if you have Apache logs, so and one line is converted into these elements. So time is comes from the Apache logs type. The tag is tag identifying the data sources. So we can use the tag for the where this event come from for the destination site. And in Fluentd uses the record the JSON object, not the raw string like the Apache logs. Because currently there are many systems can accept the JSON object natively. So for example, Elasticsearch or other web services. And the JSON object easy to mutate on the data filtering or the hard to easy to convert to the other format. So Fluentd uses the JSON object for the event record. So the Fluentd is handles the data is the data streams. And this is the data pipeline, simplified image of the data pipeline. So incoming events is passed through this pipeline from the left to right, right to left. So data is coming from the input plugin. The input plugin send data to the filter and the power and output. Of course, the event is consists of these three elements. I talk about each component. The input plugin. So this is very important because this is a start point of the Fluentd data pipeline. So input plugin receives or reads data from the data sources. For example, reading local files or polling the HTTP API or get data from the syslog or other log daemons. And the very important point is input plugin passes the incoming logs for the structured logging. So input plugin converted the raw string into the Fluentd's event structure. So in this result, Fluentd filter plugin and output plugin can easy to mutate or convert the event to the data destination format. Okay, the filter plugin is very simple. So this is useful for the mutating data. So for example, adding the server's host name to the event record, or remove the unnecessary records from the based on the field value. For example, this log level is not needed. You can use the grep filter to remove events from the data streams. Of course, filter plugin could be changed, so you can apply the multiple logic to the data streams. This is a buffer plugin. Buffer plugin is not standalone plugin, so this you can use the buffer plugin directly from your configuration. But this plugin, buffer plugin, is used inside the output because this output plugin, buffer plugin is very important for the robust buffering and retrying. So buffering the data, so output plugin can improve the performance because sending one record to the destination is very slow. So buffer plugin stores the data before the output, and it improves the performance. So for example, throughput to the right destination. This is mainly for the Elasticsearch or MongoDB plugin or S3 plugin. So internally, so Fluentd's buffer is a queue of chunks. So buffer has several chunks, and the chunk has several events. For example, 1,000 records or 100 records. And this is a unit of the one flash of the output plugins. And of course, this is can be configurable. So how many numbers in the one chunk, or how long for the output flash. So this configures the max size of the chunks or flash interval of the output. So you can trade the latency or throughput. If you want to the low latency, you can set the small flash interval. So 1 second, you can send to the immediately the servers. If you want the throughput, so larger value in the chunk size, so you can get the maximum throughput for the output, for example, S3 plugins. So output plugin is very simple because the buffer plugin handles the many concerns of the performance. So just write to the buffer chunks to the output. So this is the internal data model of the Fluentd data streams. Actually, the Fluentd is a streaming data flow collection, but the Fluentd handles the data as a micro batch. It means so I said the buffer chunks. So in the batch model, this is very hard to retry because we need to listen to the whole data to the destination when the error happens. But in micro batch model, so we can easy to retry because the chunk is small. So this is easy to retry, and we can process the small data chunks concurrently. So this is improve the latency. So because we don't need to wait this retry in these chunks. So Fluentd has several good features for the streaming log collection for the low latency. Okay, this is the example of the existing third-party plugin. So reading data from the gstat command or Kafka or other messaging queue services or RDBMS. And other plugins is more existing in the Ruby gems because there are lots of data stores in the world. So InfluxDB, Prometheus, or Hadoop, or Elasticsearch, or Kafka, or more. So you can search the Ruby gems. Maybe you can find the plugins for your databases. Okay. So next is I showed the several use cases for the Fluentd with the actual configuration example. Okay, this is a simple forwarding example. So in this case, Fluentd collects data from the two data sources. One is a local file, and one is the application. And collected data sent to the MongoDB or RDBMS. Okay, this is a configuration for this use cases. Okay, and in the Fluentd's configuration, it's Apache-like format. So we use the Apache-like the directive syntax. The source refers to the input plugin. So this means in Fluentd set up the tail input plugin and the forward input plugins. And the match directive is for the output plugin. In this case, this Fluentd instances uses the MongoDB for the data stores. And the match directive has the tag pattern. So I said the Fluentd's event consists of the time and tag and records. And the tag is used for the event routing. So we can use the data pipeline at the runtime. So this is for the performance. So in this case, in tail commands emit data with the app.apache tag, and this match pattern accepts the app.star. Star means any pattern. So tail commands tail's data is stored into the MongoDB in this case. So this is very simple about the basic configuration for the Fluentd. And the next use case is a multi-tier model. This is mainly for the high traffic environment. For example, so if you have lots of instances on the forward side, so many databases can't accept the lots of data collection from the clients. So it is very high traffic for the, this is not good for the Elasticsearch or MongoDB or the other several databases. In this case, setup aggregator is mitigate the problem of the data connection or the read-write mechanism. I want to talk about these topics, but this topic needs more and more time. So if you want to know the details of this multi-forward model, so please check my talk at the previous KubeCon. I talk more deeply about this topic. So aggregation, forward side aggregation or the destination side aggregation, and I talk about the pros and cons for the several patterns of the multi-tier. Of course, Fluentd also supports multiple destinations. So currently, one data store is not popular. So user set up the multiple databases or data stores for the data analytics platform. So for example, hot data is stored into the Elasticsearch for the recent analysis, and sending the stores old data in the Hadoop or S3 on the very large data repository. So in Fluentd, we can use a copy plugin for these use cases. So in copy plugin, send the data to the multiple destinations. So for example, in this case, copy send data to the Elasticsearch plugin and the WebHDS plugin. So this data is same and stored into each data stores. And this is only two destinations, but you can easy to add one more destination. It's just add the store before after this point, so you can send the more data to the more destinations. Maybe this is last use cases. So container logging. So Fluentd is widely used for the container logging. So logging data from the Docker and the data on the Kubernetes. So this is Fluentd's popular use cases, and there are several approaches to collect the data on the container. So I will talk about each approaches. One is this is Docker specific approaches. So Docker has a logging driver mechanism. So this logging driver mechanism is sending the container logs to the external systems, so not to standard out or local files. So this Docker logging driver has several types of Fluentd or Gelf or MOAs. So the Docker logging driver supports the Fluentd, so you can use this system, these approaches for collecting the container logs without writing the additional code in your application. So Docker logging driver collects the logs from the Docker's standard out or standard error data and send it to the Fluentd instances. So this is a configuration example of the Docker logging driver. So, and in the Fluentd, you can only set up the forward input plugin. So this is very simple. So in this result, Fluentd instances can get the Docker logs from the Docker logs directly via the logging driver. So this is Docker specific. So this approach can't be used on the Kubernetes or other container. But if you use the Docker, you can choose this approach. And next is Fluentd logger. So Fluentd has Fluentd by the community. There are lots of Fluentd logger library in the each programming language. So Ruby, Java, Python, Go, Rust, OCaml, or MOAs. So you can use this Fluentd logger library. You can send any data to the Fluentd. So this is a very application-specific data or metrics. So this approach is useful for the very deep insight. You can get deep insight for the data analytics, or the path analytics, or machine learning, or more. So the demerit is that you need to use the Fluentd logger inside your application. So you need to update your application's code. And the Fluentd side is the same. So you can use the same configuration as the Docker logging driver, because the Docker logging driver and the Fluentd logger is the same protocol between the Fluentd nodes. Okay, the next is using the shared data volume and using Fluentd's tail input plugins. Some applications can't. Some middlewares you can't modify the logging mechanism. So in this case, so for example, middleware writes the logs to the fixed path on the local file. In this case, you can use the shared data volume for the accessing the data from the Fluentd. In this case, ngx logs is stored into the mount ngx logs directory, and the Fluentd access to these logs via the shared data volume. And using the tail input plugin, Fluentd reads the local files for the collecting data. The Intel plugin is a very popular plugin in Fluentd because this is very useful for the on-premise environment. So this is the general approach in the Fluentd world. And on Kubernetes demo set, so Fluentd provides Kubernetes demo set images for the Kubernetes environment. This demo set is also uses a similar approach for the shared data volume, because on Kubernetes collected the logs, container logs to the Barg containers. So all container logs are stored into the Barg container. So I said the Docker logging driver or other approach can't use on the Kubernetes. So Fluentd resolves this problem by using the Intel plugin to collect the all container logs under the Barg containers. So if you set up the Fluentd daemon sets, Fluentd automatically reads the all logs under the Barg containers and send to the destination, populate the Elasticsearch or other destinations. So this is a summary of container logging approach. So if you are using a Docker, you can try the Docker logging driver. This is easy to use. And if you want to do the more data or the application specific data or metrics, you can use the Fluentd logger. So and update your code. And if you use the middlewares or the Kubernetes, you can use the Intel plugins collecting the data from the local file system. And system metrics is means for CPU usage or resource monitoring. Now, Fluentd can collect these data by input plugins, but I think Prometheus or other monitoring agent, for example, Datadog agent, is better because this is this agent focuses on the system metrics. Okay, this is last chapter, and I talk about Fluentd. So this is a comparison of the Fluentd and Fluentd. So I said the Fluentd is written in Ruby and C. So Ruby for the core and the flexibility for the plugins. And we are using the C for the I/O heavy or data serialization. But Fluentd is fully implemented in C. So Fluentd is very small and fast. So this is it means resource friendly. In the container area, so forward side resource is very tight. So it's sometimes Fluentd is not fit for the forward use cases. So in this case, Fluentd is very fit for the forward use cases. And Fluentd follows the Fluentd design. So Fluentd is also pluggable. So you can inject your plugins and build the Fluentd. You can easy to use the third-party plugins. For example, Kafka or Elasticsearch. So in the large deployment, forward logs from the Fluentd to the Fluentd is popular use cases. So this is a change of the, so you can replace forward side of Fluentd with the Fluentd. So this is very resource friendly on the forward side, and you can reduce the Fluentd flexibility on the aggregator side. So you can easy to reuse the all Fluentd plugins. So you can easy to connect to the any destinations. So this Fluentd is this is only the Fluentd is talk with tomorrow. So if you are interested in the Fluentd, please join the tomorrow's Eduardo's talk. Okay, this is that's all. Thank you. Any question?
So I have one question.
Hi.
Right now, the Fluentd is focused on the collected data from the machines to their log server, right? And we have a great logging abstraction layer. My question is actually, once the data can be collected from the machine to the log server, we want to avoid one thing is we may have several copies for that, right?
Mm-hmm.
That means it costs more. So I can understand that this question may not be the issue, the problem domain that currently Fluentd focuses on.
Mm-hmm.
I would like to see to hear what's your suggestion for this.
Suggestion?
I mean, we have several copies for the logs, right?
Mm-hmm.
How can we avoid that from the whole system? We just have one copy.
Okay.
So his question is that if we are using forwarding mode, you have many copies of the same data.
Yes.
Yeah, and this is so it can't share between the each destination. So so this is a problem with the Fluentd, but each plugin has their own format for the destination. For example, sometimes S3 format stores the data raw string, and Elasticsearch needs to the JSON format. So we can't share the data between the destination. So this is why currently we can't share the data between the output plugin in copy.
If they are not stored in one place, and
No, so the data is stored like in one place. But if you're going to forward from one place to a different part, likely in your node server, you're also doing some filtering and some data, some changes over the data. So you can think that you have the same data on both sides, but it's different. Because the data that you read from, for example, he explained about the container, you have the container information, but you also, if you're running Kubernetes, you need the pod name, labels, annotations. And that information is appended to the log, and then it's shipped to a different place. So, okay, it's kind of similar information, but it's not.
Sorry. Okay.
Currently, I'm using the Kubernetes and Elasticsearch and develop. So sometimes my Elasticsearch is not quickly enough, so it cannot respond in time. So in that time, the Kubernetes container will have a lot of memory. If you see this memory is high, and I think it's something error in the loggers, and it said as a buffer, some error.
Buffer full?
Something like this. So, is there any recommendation for such things?
So so the question is how to suppress the memory bloats in the when Elasticsearch is down. You mean?
Yeah, Elasticsearch is down or slow.
Yeah. So.
Elastic is low. That's
Yeah. So Fluentd is by default is a memory buffer. So it means buffer queue is stored on this own memory. So if you want to avoid this problem, you can use the file buffer. So file buffer is stored the event into the local file, so it doesn't consume the memory. So this is very robust for the such unstable destination. Or if you can use the secondary, you set up a secondary, you can use the secondary set up secondary output. It means that this is useful for the when the destination is down, so the buffer chunks is sent to the secondary. So you can use the, if you can use the S3 output, so you can send the buffer chunks to the S3 for the recovery.
Currently, I just use by default buffer size and refresh time, something like that.
Yeah, so his suggestion is that if Elastic is running slow, because sometimes when you ingest too much data, it's not good enough. So he says that you have buffering mechanisms. You have either in memory or the file system. Everybody uses the file system in production. Because if your Fluentd is getting more data, it cannot flush the data, it needs to save the data somewhere. So you choose memory or file system. If you choose memory, your container will kill at some point. So that's why he suggests use buffering in the file system. So even if Fluentd cannot ship the logs because Elastic is slow, it will retry.
So, currently we are using the Kubernetes, right? The Kubernetes saves the loggers in the var loggers containers. So I think it's already in the file system right now. So do I need some more the buffering data in file system again? I mean,
yeah, because if you container, if you're running a pod and that pod generated a log file, that pod maybe will be destroyed after a minute, 2 minutes. But what is important that when Fluentd is running, it needs to get the metadata for that pod. So if you don't get that and the pod gets destroyed, that reference does not longer exist. That's why you need buffer.